video, we'll be taking a look at the volume formula for a sphere, as well as practicing some of these other volume formulas as well. First of all, let's take a look at what a sphere is. A sphere is the mathematical name for a ball or a globe, and spheres have diameters that cut right across the center of the sphere. They also have radii that go from the side of the sphere or ball to the center. So these are three-dimensional shapes, and they're drawn this way, and they usually draw in the equator to make it look three-dimensional. So why don't you try this question without any help? The formula is here, 4/3 pi r cubed, and you've got the four choices there. Unpause the video when you're ready to begin to see the answer worked out. Well, how did you do so far? Did you place all those numbers in the right spot? And then the matter of just using the calculator to finish off the question. Before we do that though, even taking a look at that formula, my opinion is that that formula is not all that complicated. You would think that maybe something three-dimensional like this would involve a much more complicated formula than pi r squared. I mean, this is just pi r squared, but a little bit more advanced. And I think for that reason, some of these volume formulas, in fact, all these volume formulas are very beautiful because they're much more simple than I think the average person might actually believe that they would be. So type this into the calculator if you haven't done that so far, and if you need the help, here's the help on typing it in. So on this graphing calculator app, I would do 4 divided by 3, 4/3. They told me to use 3.14 for pi, and then I'm going to multiply that by the radius, which is 4.9, to the third power. And here's my exponent button right here on the calculator, to the third power. And that would be the answer that I'd be looking for. If they did not say to use 3.14 for the value of pi, you would type in 4/3 with the pi symbol. To get to pi, remember it's pressing second and then this exponent button. And then 4.9 to the third power. And it would get you a more exact answer, although this would not be exact because there is some rounding involved. By using the pi button or the pi symbol, we actually get a somewhat closer value than the answer above. So let's look for that 492.557 in the answers. And it looks to be, it looks to be a choice C there. That's the right answer. All right, next question. All right, actually on this one, there's two questions there. I'd like you to pause and try to answer both of these questions the best way that you can, considering you just started learning about this. Okay, here's another practice question of finding the volume of a sphere, and below here is describing an ice cream cone. So why don't you try both of those, and I'll give you some of the answers after you unpause the video. Well, the answer that I will show you is the one with the answer to the ice cream cone. I will check the other answer out as you submit it to me if you're in my class. So for the ice cream cone question, I think drawing a picture of it would be a good idea. If you weren't familiar with what a hemisphere is half of a sphere. I mean, everyone pretty much in the world knows what an ice cream cone and an ice cream scoop looks like if you just get a single scoop. So it's made up of a half of a sphere and a cone. And they want to know the volume of the amount of ice cream that you would be having if these were the dimensions of the ice cream cone. So I do want to let you have a chance to think about it without me helping. So pause the video and try to get as far as you can with this question if you haven't done so already. And then unpause when you're ready. All right, so what I did there is I lifted off the ice cream scoop from the top and figured out that the formula for the volume of a hemisphere, or half of a sphere, is half of a full sphere, 4/3 pi r cubed. The volume formula for a cone is 1/3 big B times h, which is the same as 1/3 pi r squared h, since the base, capital B, is a circle. We can replace B with the area formula pi r squared. We'll put in those numbers and finish off the question. And I'm just going to leave you with that to finish, trying to identify the correct answer based on all of that. If you're familiar with Spaceship Earth at the Epcot Center, it's approximately a giant sphere, and it says that there's actually a ride, and there's like a gift shop in it too as well. But there's a ride that goes in it from going to Disney World years ago. It says that the diameter is 180 feet across. So in the formula for the volume of a sphere does not have D in it; it has R. So you're going to have to make sure you take care of that properly. So do that question and try your best with this question on the satellite. It says that the length of the cylinder part is 12 meters and the diameter of the cylinder is 2. So by me reading this, it says that the 12 represents not the length of the satellite, but represents the length of the cylinder. So try those two questions out, and I'll give you the answers for one of the two. Unpause when you're ready. All right, jumping to the example with the satellite. This is the picture that they were actually asking you to think about. A cylinder with two hemispheres on either side. So maybe you could have been a little chicken with trying to do this out on your own first. And let me give you a suggestion. If you take a hemisphere, a half a sphere, and you take another hemisphere that's the same size and you put them together, you basically created a full sphere. So basically what you need to do in this question is find the volume of the cylinder and find the volume of a full sphere and then add them together. So let's see how you did. Don't be a chicken. Give this a try. So hopefully you didn't chicken out. The volume formula for a cylinder is pi is big B times h. And if the diameter was 2, it is 2 meters for the diameter. It means 1 meter was the radius. It doesn't say to express the answer in terms of pi. So altogether from the cylinder, I'm getting pi times 1 squared times 12, which ends up being just worth 12 times pi. For the sphere, or the two hemispheres together, we're going to use 4/3 pi r cubed. If the radius is 1, then it just becomes 4/3 times pi times 1 to the third power. 1 to the third power is 1 times 1 times 1, which is 1. So as it turns out, the volume of the hemispheres together, grand total is 4/3 pi. So the total amount of volume in terms of pi would be 12 pi from the cylinder plus 4/3 pi from the sphere. And this would be an acceptable way to write your answer. But I want to write my answer in the simplest way possible. So I want to combine those like terms. And to do so, I have to think about some fractions here. So 12 pi is the same thing as 12 pi over 1. So if I want to add fractions together, I need the denominators to be the same. So I'll multiply the bottom denominator by 3, the bottom here, the denominator by 3, and the top as well by 3, the numerator. So 12 pi over 1 becomes 36 pi over 3. And then adding them together would give me 40 pi over 3, or 40 pi over 3 as the answer in terms of pi. Well, Might have been the toughest one yet. And then here's one last look at the final question that I'd like you to work on, which has 5 parts to it. And although planets aren't exactly perfect spheres, we would like to consider them as being spheres to figure out these questions here.